Hello everyone and welcome to the class for Geotechnical Engineering. I'm Professor Kakade and welcome you all for the Geotechnical Engineering and we are learning the first unit introduction and index property. Slowly we are going ahead and covering most of topic and concept related to the geotechnical engineering. And especially we are doing this index property topics, covering this index property topic to understand what is exact behavior, behavior judged by the this particular index property, so that whatever the soil behaves is depend on the its index property. That's why it change its whole characteristics. So the index properties are important from the many point of view, and we are learning it. So in the last lecture we have discussed about the two index property, which is degree of saturation and density. Okay, so degree of saturation and density. Here the saturation shows the volume of water occupies the total volume from the volume of void. So here how much water is filled in that void is considered, and the whole scenario related to it is very important. Okay, so this important because to understand how the soil will behave when it came in the contact with the water. Okay, how the capillary, how the soil behaves in the case of a capillarity, and what will be the effect of that particular soil which showing a particular amount of degree of saturation to the foundation. Okay, in the next density. So the density, it means that the particle of a soil compacted to each other. Okay, how much it are near to each other is considered in the density. So this is expressed in kg per cubic meter. Okay, so in the last lecture I was to telling you that if one concept is of one container of a 1 meter cube is containing cotton, and in another container of a 1 meter cube containing a steel. So obviously the steel will be heavy because the particles of a steel are compactly stabilized in the particular volume or less volume. Okay, so this is it. In the next in this we will discuss about the density index. So the what is mean by density index? Okay, so the density index is the showing the state of the particular soil when it show it is in the loosest form and in a densest form. Okay, so when it is a representative number which is showing that how much the soil been densified or compacted, so that the void which is present in the soil. Okay, the voids which are present in the soil. So the density index showing us how much the soil been compacted from the initial stage to the final stage. Okay, so here is the definition. Okay, a measure of comparative denseness of soil with respect to its loosest and densest state is known as a density index. Okay, it applied to the cohesion-less soil such as sand and silt, because cohesive soil already been compacted and consolidated due to the high cohesive property, and the cohesionless soil like a sand and silt contained a large amount of voids, So that we are considering here, it is a formula which is a ratio of Emax minus E divided by Emax minus E minimum. So the Emax is the when void ratio is at the loosest state. Okay, when soil consider the one soil is dig from the one pit, consider soil was dig from the pit and it is stayed stored at the ground. So when it is stored on the ground, it is in a loosest state, and E is the actual whenever without losing state or without dense or compaction. E is the actual void ratio. E max and E minimum. E minimum in the sense that E is the minimum value. When E will be the minimum value, E is the void ratio, like volume of void to the volume of solid. Okay, so when will be the E value is minimum? When there is a void ratio is at the minimum state. So when the void ratio is at the minimum state, then the whenever the load been applied on the particular soil. Okay, when the load applied to the soil and the soil get compacted, so that due to the force the particular, okay, so particular particles get closer to each other, the void volume of void or void becomes a less in the whole soil mass. Okay, Emax, the void ratio in the loosest state of the soil, minimum void ratio in the densest state of soil. Okay, and E is the void ratio in the natural state. So the minimum, okay, in the loosest state, when E equal to E max, when actually E or the actual state of the soil is the loosest state, in that situation ID become 0. ID in the sense of density index, and when the soil is in the densest state, E equal to E minimum. Okay, whenever the E is in densest state, ID become 1. So it, that kind of the situation never been occurred. Okay, so sometime for the knowledge, E max, maximum E max is 0.96 or 97, and E minimum is 0.367. Sorry, this is the values of E max and E minimum, so that in the loosest state the soil is at the 0.98 and 0.37. Okay, in the natural state of ID lies between 0 to 1, and the density index is varies from 0 to 100%. This is a percentage representation. Okay, so here you could see that density index and compaction state, so that the value is lowest, the density is minimum. Okay, as the ID increases, density increases. Okay, so ID never been achieved at 100%. Okay, it will be become at the 97, 96, but not will be the 100%. Unit weight is the unit weight is the index property. You have studied in a SOM also that volume, total weight upon volume. Okay, how much the weight carried out in the particular unit volume is known as an unit weight. Okay, it is also known as weight density. This is the same concept as the mass density. It is the basic weight density. Percentage of air voids. Okay, it is the percentage of air present in the voids. It is the ratio of volume of air to the volume of voids. So that It is represented in Na, volume of air to the volume of voids. Okay. So the remaining part we will see in the next video.